Hey Algebra 2, welcome to the final review for Semester 1. Be brave. Go all out for these finals. Why not? It's once in a lifetime. High school does not come around again, right? So why not go all out now? You can always rest afterwards, okay? Okay, first study options that you have to get prepared for this final. You have your review packet that we've been going over in class, which is also your homework, so that is due on the day of the final. We have your flashcards that we created on Friday. Go through those, fill those out, and kind of use those to help you study. If you don't know how to use those, come in and I'll show you how to use those. Final review videos on Google Classroom. They'll be posted. This is the first of the 4. Go back to your old IXL assignments. As long as you're going through Unit 1 through 4, it won't affect your grade at all. The only one it will affect is your Unit 5 IXL assignments, because those still haven't been graded yet. Also, you review in your notebook. Go through the examples that are in there. There's lots of different examples to look at and go through in that book. And review session next week, Tuesday, Wednesday, and Thursday in the morning, 7 a.m. to 8:15. How should you prepare yourself mentally, physically, spiritually? First of all, have fun. You got a 3-day weekend. Take advantage of it. Hang out with some friends. Go play some soccer or basketball. Get some energy out. Do it this weekend. Not the night that you have to study, when you should be relaxing. Watch a Warriors game. You guys are awesome, right? Yeah, I know you think so too, Draymond. You guys are awesome. But you know what? We're talking about relaxing, okay? I want you to have fun, but keep it down a notch, okay? God, that looks more relaxing. All right, cool. Have some tea. Tea is relaxing. It helps your body relax. Get some sleep. Get some sleep. Get some sleep. Research shows it improves your performance on tests by 10%. That's a whole letter grade. Going from like a D to a C, or a C to a B, even a B to an A. Get some sleep. It's very important for these tests. All right, guys? All right, I will see you soon.
Finding the slope and the y-intercept, number 1. And as I go through this, I would recommend you have your packet next to you so you can kind of follow along, and maybe if you haven't done certain problems, try it yourself and then watch the video. So we need to find the slope and the y-intercept, and in order to do that, we need this to be in y equals mx plus b form, or in other words, slope-intercept form. So let's change that first. So let's rewrite our equation. And I'll draw them a little line so I can stay organized. Now, I want y to be on the left, and it already is, and I want x to be on the right, it already is. So my last step here is just simply to divide everything by 4. Okay, that cancels out. I get y, let's write it over here, y equals 3 over 4, 3/4, and x plus 8 over 4 is 2. So then that means our slope, which is m, is equal to 3/4, and our y-intercept b is equal to 2. Okay. Now let's scoot over here to the right to number 5. I know we're kind of jumping back and forth, but I'm going to go left and right. And this one, we're going to need to do similar. We need to rearrange this equation in order for it to be back in that y equals mx plus b form. So I want my x's on the right, y is on the left, and y should be by itself. So the first thing we're going to do is subtract 5. And remember, if I do it from this side, I must do it to the other side. So that goes away. I'm left with negative 3y over here. And then let's rearrange this side. I can't add negative 5 and 6 together because they're not like terms. So I'll just rewrite them. And the last step, just like before, divide everything by that number next to the y. That cancels out. Then we get y equals. Looks like we've got a negative and a negative on top of each other. So that means they'll become positive. So that'll be 5 over 3 x. And if you notice here, we have a plus and a minus. That will become a negative. So after I divide it, 6 divided by 3 is 2. So for our answer, our slope is 5 over 3, and our y-intercept is -2. All right. Now let's scoot on over here down to the left. So now, given the function f of x equals 2x squared minus 6, find each of the following. So we're going to evaluate for each of these x values. In other words, we're going to plug in these values into this original function. So what that's going to look like is I'm going to plug in the -2 here, and I'm going to plug it in the 0 here. And before I evaluate, I'm just going to write it all out. And then here I'm going to plug in the 3 this time. And here I'm going to plug in a 4 this time. And I just have to figure out what is the value for each of these x values, or what is the y value, or solution to this. So now the first one, I've got -2 squared, that'll be 4, times 2 is 8, so 8 minus 6, which is equal to 2. There's my answer for the first one. And then the second one, 0 squared, is just 0, times 2 is again 0, so that one goes straight to -6, because the 0 cancels out everything. Then here I've got 3 squared, which is 9. Then 9 times 2 is 18, minus 6, which is going to be 12, so the answer is 12 there. And then here we're going to have 4 squared, which is equal to 16. 16 times 2 is 32, minus 6 will be equal to 26. Let me just make sure. 26. Yes, so it'll be 26. Okay, so that's how we do that. It's just evaluating, plugging in the number. Now here, we're trying to prove trying to see whether this statement is true or not. Is the value of g of -2 greater than the value of g of 6? In order to find that out, we're just going to have to evaluate those two x values. Now, let's just plug them in and see what we come up with. So 6 here, in place of the x. So now -2 minus 5 is -7. And if you square that, it equals 49. And then the next one, g of 6, 6 minus 5 is 1, and we know that 1 squared is 1. So that means that g of 2 is greater than g of 6. And so that means that this following statement up here is true. So it is true. Okay. Now the next one here, simplify each of the following. Okay, just so you know, like when you have these types of situations, really all you're doing is combining like terms, and you may have to do some multiplication in between. Now here, looks like we're going to have to distribute. So we'll distribute that 3. That's our first. Remember, you got to think order of operations, PEMDAS. It goes first, and parentheses goes first, and we do have parentheses. And then I get 3x here, minus 4x, rewrite everything else. And now just combine the terms that are like each other. So now I have 3x squared and -4x. That combines to -x squared, or -1x squared, but we don't need the 1. And then the next terms I can't get rid of those. The next terms I can combine are 3x and 5x. So it's just simply 3x plus 5x, which is 8x. And there is our simplified expression. Okay, let's do the same down here. Get this little circle out the way. Move that out the way too. Let's put that answer over here. We need that 8. There you go. Okay, now for this one, same thing. Let's pick a new color. Let's distribute the 1 here and here. So now we get -x squared plus x, because that changes the sign. And then just rewrite the other terms. Plus x squared minus 8x. Combine the like terms here and here. Those cancel each other out because they're opposites. -x squared and plus x squared, that becomes 0. So then what I'm left with is x plus x and minus 8x. So it's really 1 minus 8, which is going to be 7, 7x. Okay, and let's do it again. Green, distribute this 2. So it's really all the same steps, we're just doing different problems. Distribute that 2, I get negative 2x squared plus, sorry, not plus, because that is a negative in front. Changes it to a negative 2x, and then rewrite the rest, negative minus 7x squared plus 4x, combine the like terms, negative 2x squared plus negative 7 squared, negative 7x squared, that becomes a bigger negative. And I add 2 negatives, that becomes a bigger one, so it's 9. So we're done with those. So now I have negative 2x and positive 4x, and those combine to positive 2x. And there's my answer there. Okay. Now let's move to the right. Let's pick a new color. It's a little purple. How about simplify this expression and put in standard form with highest degree term first. So again, we are just simply combining like terms, but we just need to make sure that we are in standard form, which means that we're going to have the highest exponent term first. Okay, so let's just go through it. So first, I got to distribute this negative. Okay, so first I'm just going to rewrite the first polynomial on the left, or trinomial. And then let's distribute the negative. So now I get minus 5x cubed minus 3x squared plus x, because that changes the sign. Now again, I'm just going to combine like terms. But I need to do it from highest degree term first. So let's start with the x cubed, and there's only 1. So let's rewrite it with 5x cubed. I'm done with that. And then the next one will be the squared, x squared. So I have 2 of them. So 4x squared minus 3x squared would just be x squared plus x squared. Done with those. Then I've got negative 2, Then I've got negative 2x and x. So it's just negative 2 plus 1, which should be negative x. Done with those. And the last term I have here is that little 3 right there. So now it's just plus 3. And that is from highest degree to lowest degree, standard form. Okay. Let's move on over here. And let's do orange. So this one, we're no longer subtracting and adding. We are multiplying. And this happens to be a 2 by 3 situation. Whenever we have more than 2 terms in the parentheses, we're going to have to use a box. Now, if it was 2 terms such as this, x minus 3, and there's 2 terms here, 2 terms here, that's a 2 by 2, we can just FOIL. But here we've got 3 terms, so we can't just FOIL. We're going to have to use a box. Anytime there's more than 3 terms, you have to use the box method. Now, there may be other methods you could do. Distribute one thing at a time. You know, distribute the x throughout and then distribute the 2 throughout, and you'll get the same answer. But I like to use the box. It's simple, straightforward, and it keeps you organized, so you don't mess up. So let's do it again. The type of box you need to do is a 2 by 3 box. If I got 2 terms by 3 terms, I make a 2 by 3 box. Okay, so we'll do black in contrast to that. So now you put the smaller binomial here, then you put the trinomial on top, x squared plus and positive 5x and positive 4, and then just multiply it through. Now I get x times x squared, this is x cubed. I get 2x squared from 2 times x squared. Then x times 5x is 5x squared. Then x times 4 is 4x. And then 2 times 5x over here is 10x. And then the last one is 2 times 4, which is 8. So now what you're going to do is you need to add all the like terms. And what you'll notice is that the like terms are at a diagonal from each other. And remember, do this in standard form from highest to lowest. highest degree to lowest, so we'll start with the x to the 3. There's only one x cubed then. Then we'll have 2 plus 5x, 2x squared plus 5x squared, that's 7x squared. Then 10x plus 4x, which is 14x. Done with those. And then the last one is just 8. And there is our new polynomial after being multiplied. Okay, now let's go over here. Now we got to simplify this radical expression, and we need to use the birthday cake method in order to do that. So if you remember the birthday cake method, we are basically breaking down this numbers into its smallest part, into its smallest prime parts. So first to do that, first thing we do is break down the numeric value in there, which is 54. And we think of the smallest prime number that you can think of that divides into 54. Well, 2. Okay, I divide that by 2, I get 27. Then what's the smallest number I can divide into that? Not 2 because it's an odd number, but I know 3 goes in there. 9 times, so I get 9. And then what's the smallest prime number I can put in that? Well, 3 again. And so that goes into it 3 times, that goes on top. And then what's the smallest prime number I can put into that? Well, 3. And then we always finish it off with our little birthday candle, which is our number 1, because that 3 goes into that 3 one time. Now, if you remember, the numbers here on the slant are the prime numbers that we broke it down into. So now let's rewrite it. Now don't forget, you need to include that 3 out there. That's important, both for reference as you go through it and for your answer. It needs to be there. So now write all these prime numbers you just came up with. 2 times 3 times 3 times 3 times 3. And if you need to go back and reference where this is at, I'll show you. So, go right in here. Well, let's flip to that page. I believe it's in Unit 3. Flipping back. Keep going. Birthday cake method. Oh, there's our birthday cake method right there. So you can look at that in case you want to know how to do the birthday cake method. And then the next page shows us how to break down radicals and doing this. And doing the same thing. So it's all there. The steps are to the left, and so that should help you go through this if you need more reference. Okay. So let's get back to our notes. So now we've got that 54 broken down, but we also need to break down the variables underneath, the x and the y. So break that down into its smallest parts. So we got 4 x's, so draw 4, and 3 y's, so write 3 y's. And if you're following along in your notes, you'll see that now you circle groups, and that the number that you circle in the groups is based on this number here, which we call our index. So if it's 3, that means we circle groups of 3. I see a group of 3 3's, a group of 3 x's, and a group of 3 y's, and that's it. So now what happens is if you circle a group, you take one of those out from each one. So I take a 3 there, an x here, and a y, and those come on the outside. So I'm going to put those on the outside now, and that'll be my next step. 3, x, and y, and the rest of them just cancel out. And then what's left underneath is this 2 and this x. So now it's just 2x. Let me rewrite my radical here. It's a little smaller. But the last thing we need to remember to put is the index. Don't forget that. I always saw that on that. I remember seeing that on the test, people forgetting that index. Okay, and that would be how we finish that. All right. Okay, let's go on to page 2. So you flip the page. Now we need to state the vertex of the graph for each of the following. Well, in order to state the vertex, we need to know where does the vertex x and y value even come from? Because remember, vertex involves an x and a y. Well, if we look at vertex form of a quadratic, it's a times x minus h squared plus k. And the h and the k give us our vertex. But we also need to remember that x here, just a second, that x, what's going on here? You need to remember that, okay, it thinks hold on, I think I got this. Bring it down a little bit, that should help. The x is a liar. So, if it's negative in there, that means that it's actually positive for the vertex. So, for instance, here, we have -1 in there. So it's not, the x value is not going to be -1, it's going to be +1. And the y will be -12. And then here, it's -3, so we'll have +3. And the y value will still be 21. So the y value doesn't change, it's just the x value, the h, in the middle there, which where x is a liar, so you're going to be the opposite. Here, again, we have a negative, so we're going to have another positive, and -2 for the y. Just remember that y comes from this number on the outside, the k. And then again, these are all negative, so this one is going to be another positive, 4 and -23. So let's just say I have this example, x plus 3 times x plus 2 plus 5. Well, this would be a case where the x value would be -2 and 5 because it's plus in the middle. Okay? Move on to over here. What is the vertex of the graph? Well, the vertex is the point where the graph is split in half, and that happens to be right here. Okay, it's also a max or min point, max or minimum point in the parabola itself. Here it happens to be a minimum, and that vertex point is simply 6 and 4, and that's it. All you need to do is state what the vertex is. Okay, the next one. What is the domain and range of the function graph? Well, domain, if I can get a little line here. Domain, if you remember, is as we come in from the left, what happens, or what do I end up touching? And here, I end up touching this arrow here. So, as I come in from the left, you see that I bring my line, and all of a sudden I touch this arrow. So what that means, coming from the left, it's coming from a negative infinity. So that's what the x values are doing as they go to the left. And then there's going to be the same thing. Let's get rid of this line real quick. Okay. So again, it'll be negative infinity to the left. And then as x values go to the right, they go off to positive infinity. Okay? And if I were to drag a pencil across the screen here until I touch that arrow would signify that it's infinity. Now range, I'll remind you, domain is from left to right. That's why I started with negative infinity. And range is from going from the bottom to the top. So let's come up from the bottom. I'm going to attempt to draw a little line here. And I'm going to bring this line up. Let's see if it lets me kind of smooth it out. It's not really letting me go very smoothly. Well, as I go up and hit that line, let's take that out. That's not helping you guys. That line is eventually going to hit right there on the bottom of the parabola. And that's the first point it's going to hit. So it doesn't hit an arrow, it hits a point. And if it hits a point, that means we draw a bracket. And that point happens to be 1, the y value. Because remember, range is the y values, domain is our x values. And then coming from the top, that arrow is going to hit, that line is going to hit more arrows. So that means infinity. And y values going in that direction are positive, so it's positive infinity. Okay? Now we'll move on to this one. Write an equation for the axis of symmetry. Well, remember, the axis of symmetry is simply the line that splits the parabola straight down the middle to where both sides are symmetrical. And that is a vertical line. If you remember, vertical lines are VUX, meaning vertical, and the U meaning undefined, and the X referring to X values. So X is going to equal whatever, the equation will be whatever that X value is at that point, and it is -1. So our equation for the axis of symmetry is X equals -1. Okay, and again the U means undefined, because that slope is undefined. Now, what is the equation of a function that translates this function here, f of x, or x squared, left 4 units? So I want it to move to the left. This is what it looks like, by the way. This is what x squared looks like. And let's do this. So I want it to move to the left 4 units. It's going to go that way. Alright? So if it goes that way, that means I'm making a horizontal movement. And when I make any horizontal movements, that means I'm changing what I actually plug in to our function. And remember, with horizontal movements, x is a liar. So even though we're moving to the left, which is considered the negative direction, I'm actually not going to subtract 4, I'm going to add 4 this time. And if I wanted to, so that would be my new function there. And if I wanted to go the other way, 4 units, in the positive direction, instead of x plus 4, I would do x minus 4 on the inside. Okay? Now, come over here. Now, write the functions below in order from widest to narrowest on their corresponding graphs. Okay. Now, if we graph this, you could easily see which one's wider, which one is narrower, but we don't have that luxury right now. Now, on the test, you could go through and do a little input-output table, pick like, maybe 5 points, and try to graph all these. Pick points from -2 to +2, graph it, and you'll probably be able to see which one's wider and narrower, if you want to just do it the long way. But if you want to know how the formulas work, well, I basically need to know, what is this number on the outside even doing to each of these graphs? Because that's the difference between all of them, is this number that's getting multiplied on the outside. And if you look in your notes, whenever I multiply a number on the outside, I'm stretching and compressing in the vertical direction. Okay? Now think about it. If I took a rubber band, here's my little rubber band, and I stretched it this way and this way, what happens to it? Does it get skinnier or wider? Well, of course, it gets skinnier. Right? And if I compressed it in both directions, then all of a sudden it kind of starts to get a little wider and widens out. Okay, so keep that in mind. So, if the number in front of the function is less than 1, if the absolute value of it is less than 1, but still has to be greater than 0, the absolute value, so it could be a negative or a positive number, because the absolute value of a negative and positive number end up becoming a positive anyways. If it's less than 1, in other words like a fraction, it's going to cause it to compress. So in other words, it will get wider. If it's greater than 1, the absolute value of that number, such as the 2 and the 7 in these cases, it will cause it to stretch and get skinnier. So in other words, the smaller the number is, the wider it's going to be. So what we'll do is we'll just rank them. So the smallest number we have here, or the smallest absolute value of a number, is the negative 1/8. It's 1/8 is smaller than 1/4. But the next one up would be 1/4, so that would be number 2. And then after that would be 2, or p of x. And our last one, oops, sorry, I just wrote 2. I meant to write 3. That would be our third. And then this would be the fourth. That would be, the first one is the widest, and the fourth one is the narrowest. Okay? Now, state the vertex, the axis of symmetry, and the y-intercept. Okay, so and also whether it opens up or down. Okay, so let's start with the vertex. Vertex, we need an x and a y value. The x value is equal to, this is something in your flashcards, negative b over 2a. Okay, so let's find that. So negative b, so b is negative 8, so that means I'm going to plug in negative 8 over 2 times a happens to be negative 1. So let's cancel out all the negatives. So the top, negative times negative 8 becomes positive 8, and the bottom becomes negative 2, and so that simplifies out to negative 4. So the x value there is negative 4. In order to find the y value, I simply just plug that number back into the original equation. Let's plug it in. And I get 16 plus 32 plus 7. 16 plus 32 is 48 plus 7 is going to be 55. Okay. Oh, and you know what? I just realized that there was a negative in front of all that. There was actually a negative in front of this. I was like, that can't be right. So what this works out to be is negative 16 plus 32 plus 7. So negative 16 plus 32 is positive 16 plus 7, and which equals 23. I was like, that doesn't sound right. Sounds a little big. Okay, so negative 4 and 23. Okay, so now the axis of symmetry. Axis of symmetry is simply the x value of the vertex. Or x equals, okay, negative 4. Okay, now this y-intercept is our c value, which happens to be 7. So y-intercept is 7. Done with that. And then does it open up or down? Well, the a value is negative, so that means it's going to open down. Okay. Now this one here. Find the vertex for each function. Well, which of the following functions has its vertex above the y-axis, x-axis? Well, what you're going to need to do is find the vertex in each case. And so you're going to need to present these in vertex form in order to find that. Alright, so, or you could use the standard form equation as well. Okay, so this, what I'm going to do here is I'm going to do it two different ways. Okay, I'm going to present it like in the vertex form, and I'm going to present one standard form. So this one, let's just put this this number 1 in vertex form. So this is also equal to 1 times x minus 4 squared plus 0. Because all I did was add our arbitrary number of 0. It doesn't change anything, and a 1 doesn't change anything either. But that does give us more information. Now I know my vertex is 4 and 0. Okay. Now this next one, let's just add in our missing values. Okay. And we know that the vertex, the x value of the vertex is negative b over 2a. So negative b would be negative 0 over 2 times 2. And I don't really have to go any further because I know that 0 on top of anything would be 0, right? So it'll be 0. And if I plug in that x value back into, it'll simply be 0 again. Okay? Okay, now the next one, I'm actually going to do this in vertex form. Actually, you know, I think it'd be easier just to put it back into standard form. So we'll do x squared plus 0x minus 8. And again, I already know that if b is 0, that my vertex will be 0, because once I plug that in to say negative b over, which is 0, over 2 times 1, which is the a, that's going to be 0 anyways, right? So if I plug 0 back in to here, that's 0, that's 0, and all I'm left with is negative 8. So then my y value will be negative 8. And then here, again, remember x is a liar. Here's the one that's in true vertex form. So it's not plus 3, but negative 3, and then the y value is 5. So now we just have to say which ones are above the x-axis. Well, we're just looking for the ones that have y values that are greater than 0, because it's asking what's above. And if it's right on the axis, that doesn't mean it's above. So that's why these first two are actually not above, because they're right on the axis. This one, our y value is negative 8, so that's below. But this one here, this last one, is positive 5, which is above. So that one is above the x-axis. Okay? Okay, I think I will stop there. That was the first 2 pages. And then you can watch the video for the next one.